Alright, welcome again. This time around, we're going to still be working with this bad boy, the spreadsheet or the CSV file that we downloaded online on Kaggle. We've looked at that multiple times, but we'll be using SQL Server Management Studio to connect this in there. So let's go in there, check it out again. I think we were right here. Awesome. So yep, we downloaded this from here. Looks good, but this time around we're going to go and open up SSMS and play with it on there. So let's minimize that and wait for it, it's loading up. And in 5, 4, 3, 2, 1, and go. Or not. Awesome. Well, we tried. We'll still have that running shortly. So we've looked at LibreOffice Calc. Looks good. It has some shortcomings. We also looked at that same data set with Google Sheets. It looked good. We also needed to check it out with Microsoft Office 365. So now we're going into SSMS, connecting to our server, and it loads up. Everything looks good. We have a few databases in our server. The test database doesn't really have much in there for us to test. I'm going to collapse that again. We created those tables as well in our 100 days IT challenge database. And in addition to those tables, you see that I do have a new schema that we created earlier, and I added some stuff in there. So I'll walk you through that process. To begin, let me go ahead and open the instructions which I outlined. You'll see in here the instructions for USA election. So a few things we need to do. It's always good to document your stuff as well. We download and import the CSV file. We already downloaded it. To import it, it's very easy. We select the database where we want to import our table into. Right click on it, select task, and then from there we can go ahead and import a flat file. Okay, we don't want to export data, we don't want to import data, we want a flat file. Flat file is CSV file, a JSON file, those are all flat files. Okay, so when we select it, it's going to ask us to put in our social security number, email, password, phone number. I'm kidding. So we're going to go in and just follow the wizard. Okay, if we don't need to check it every time, that's totally fine, but let's go to locate our file. It should be somewhere on our desktop, and there it is. We should be good to go. Do we want it in this schema? No, we want it in, we wanted it in our schema, but that's okay. Before I do that though, let's just put in the DBO schema. So it's going to be right here, very similar to that. Or not. So let's cancel that. And I'm going to go ahead and open another file. Cancel, yes. And open another file so I can drop these tables. But before I drop them, let's take a look at what the tables look like. So open the top 1000. You can see it automatically selects the state. We do have at the bottom here 51 rows. You can also check it out in your messages. 51 rows and the results. These are the data that is gotten from our imported or normalized table. So again, the parties should be a very small table, just those parties that we have in the data set. The candidates, that will be a bigger list. So it's going to select just the top 1000 because there's definitely more than 1000. But since I'm sure it's not going to break my database, I can take off this top 1000, which is limiting the results, so that we see everything all together and execute this. Now, if you check out the messages, this number looks very familiar with what we've been seeing before. The one that is not in there is the header row, and you can also see that in there. So you can see how fast SQL Server pulls all of this, but it's only possible because we're able to normalize this data. So let's close all of these. Nope, I don't want to save it. Close that. I don't want to save that either. And close this. I don't want to save it. So we're back to our instructions. So before I proceed, I'll go ahead and open one of those files again because I need to drop those tables. So I have a file in here that says drop US election tables. So all these tables, I'm going to drop them, except I think I'm going to drop even the president table as well. Because I need to import everything from scratch. So drop table, Vitus DK, the schema is in there, USA, not candidate, 1, there you go. And now if I execute this, it's going to drop all my tables and I should be squeaky clean right here. So let's execute it. And oops, we cleaned everything up. Let's go ahead, refresh this. And now they should be all gone. All gone. Good. So let's start from scratch and recreate everything. I don't want to save this. I'll leave it as it is. All right, so we downloaded it from Kaggle. We need to import it, just like I was showing you earlier. Very easy. Not there, but in our database. So not rename. Right click simply and task, import flat file. Next, 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 next. Select the file located somewhere on our desktop. And we're good. Now we want to make sure we select the right schema. Remember, a schema is just a container because you can have multiple schemas in your database where you sort out and access the security between your stuff and other people's stuff, your team and other people's team. So yeah, it gives you an idea what the data looks like. You know, since I did it earlier, I know there are some blank spaces in there. There are some voters who did not put in names of candidates, so we had to make some changes in there. So we'll just go ahead and make sure that, hey, does it allow nulls for candidates? Yeah. Does it allow nulls for party details and so on and so forth? Everything looks good. Do we need a primary key? Not really, because this very first file we're pulling just has everything, just a flat file. So we're going to have to normalize it later. So let's just go ahead and do next. Everything looks peachy and finish. We have an error. What error is that? It says that the column right in does not allow null values. Okay, so let's go previous, and make sure that right in allows null values. So we now allow null values and we should be good. And that's the error. Sometimes you see errors, don't freak out, just read it, go back and fix it, and we should be good now. Next thing you have is just warnings. The warnings will probably tell you there are blanks in there. Up to 3 cells of data have been dropped during the insert, and that's in the right in column, which we just said. Okay, so fine, we're good to go. Note that, pass it on to your team lead or whoever you're reporting to, just to make sure that they are all good to go. So we've been able to download and import, follow the instructions in the wizard. Now we want to explore the imported unnormalized table. Where is it? We don't see it because we haven't refreshed yet. So I click and refresh. There is a table. How do you explore it? You simply right click and select the top 1000 records. And you don't have to type the script, it automatically writes it, and now you can see how it looks. It looks just like the spreadsheet or the CSV files. And now we can go ahead and play around with our stuff. Other things you could do is you could probably count, right? See how many of them are in there. So let's write a new query that will say select, if I can spell correctly, use the count. We already talked about functions. Check out the video. We're going to count. Asterisk is not a good way of doing it because if you're looking at a big database or big data source, it's going to take up resources. So use one of the keys, use one of the columns that you're familiar with. I know the year is present in each one of those records, so I can select the year and count it from our table is in that schema. You type it in, it helps you with the autocomplete, and that's good. So it's going to count everything, and it tells me, okay, there are 4,287. That looks good to me. I can even go ahead and write another query that says select distinct. In this case, I want to count how many states are in there. Select distinct states. The same from clause, so I don't have to type it and make a typo or mistake. I can execute both of the queries, and they're going to work just fine. The first one gives me one result, the next one gives me all the states. Okay, it tells me there are 52 records returned. That's because if I check in my messages, the first row, the first query gives me 1, the next query gives me 51. So that's how you should be able to keep track. All right, now I'm pretty sure there are 50 states and the District of Columbia. So I can also check, maybe I want to see select distinct. Okay, I already counted the states, I counted the years. What else do I need to count? I did not count the years. Okay, so let's see, select distinct year, and I'm going to do the same, copy and paste, execute. This time around, it tells me there are 12 records, so 12 years from 1976 to the year 2000. So everything looks good. At least I tested those out. I know my data looks clean. And maybe instead of doing it this way, I might want to also do order by year to make sure that everything is in the right order, and I can actually make sense of it. Order by state, and if I execute it, now I can see the state starts with Alabama and scrolling down to Wyoming. The year starts with 1976 to 2020. Good to go. All right, a few things to point out. The data that we imported, which is right here. Nope, I closed it. Right here. This data has some columns that are not very friendly. In here, we did not get purple colors because Microsoft makes sure that when it does its automatic queries, it slaps those square brackets around it to make sure that there's no error. But if you see, mine has year is purple, I think that's the right color, or magenta, and state is green, sorry, blue. All right, so normally, just like your IDE, just like your code editor, Visual Studio Code, The software tries to help you to make life easier. So all functions will have a magenta color, which is why here is magenta. It's not a good name for a column or a table. And the same with state is a keyword which we want to avoid using for our columns and tables. So when I start writing my code to normalize this, I'm going to avoid using those names. So those are a few best practices for you to remember so it doesn't throw you off when you look at it. It looks like, why am I having a function without any arguments? So that might throw you off sometimes, especially if you're having a stressful day. All right, so we can close this out. I'm not going to save any of that. We can also close this out and go back to our instructions. So we validated that the imported information is good. Now we need to design and normalize that database. Okay, simply put, based on the data that's in there, we know that the entities would include the states, the parties, and the candidates. So we just need to create tables for that. We don't need a table for years because each candidate is tied to a year. The parties go across the years, the states go across the years. A candidate could appear multiple times for each year and so on. So we're going to put the year inside the candidates. So let's, for the sake of time, let me go ahead and open the file that we used to create and go through that for you to understand. Yeah, I want my lines to be so and so, that's okay. So first we're going to create a table. Again, I'm using that same schema, right? Instead of calling it state, which I just told you about, I'm calling it USA state, all right? I'm giving it a suitable ID and a name, throwing an abbreviation in there and all these other columns that are coming in from the imported data. If you expand this, you should be able to see the columns that are in there. So I'm avoiding state. I'm using state name, state ID, USA state. Now I'm using tiny int instead of int. There are a few things to remember with integers. Let me scroll to the bottom. Integers have ranges. I'm using tiny int because the maximum range is 255. I know that I'm not going to have more than 255 states. Obviously, they're just 50, 51. So I should be good. It helps me to have an efficient database and also works with the performance. If I use int, I'm going to be saving, taking up so much space, which I definitely am not going to use. So it's good to use tiny int in that case. I'll show you an example of when I use small int. All right, so let's go back to the top. Sorry, I did that too fast. And we talked about automatic numbers, automatically generated numbers. So I'll use an identity so I don't have to go in and enter an ID each time. It's going to automatically start from 1 and increase by 1. And the system is going to remember the number for me. I don't have to sweat it. Make it a primary key, for integrity issues and so on. Primary key automatically is required. It's not null and it's unique. So I don't need to add all those other constraints on there. The name, I know the name of the states are not going to be that long. It should take 50 characters. That should be good. If I go ahead and put 255 characters, it's just going to take up space again. So I need to make sure my app or my space, all my stuff is managed appropriately. And instead of varchar for the abbreviation, I know the abbreviation of a state is always going to be 2 characters. So I do char2. And that's it. The rest of them tiny ints because I know they are all small numbers. There are no huge numbers in there. And that will be it. All the information I need for the state. It was mostly the name that I needed. So everything else is just in there for you. Once I do that, I should be able to create my state. Similarly with the party, I just went ahead and slapped in USA in front to be consistent. Need a party ID, still tiny int, because I know the parties are about 5, 10, 20, 30. It's never going to get to, well, let's not say never. It's not going to get in up to 250 anytime soon. So identity again, to automatically get that. My primary key, we talked about it. Give the name of a party. I added an abbreviation just to make life easy for me. DEM for Democrats, LIB for Liberals, OTH for Other, and so on and so forth. So show you how I get those values, REP for Republicans. And added the party color. This is going to be null for now. This can be null, that can be null. That is just for futuristic use. Maybe add a symbol in there if you want to get fancy. All right, now the important one is the candidate table. And I did have a typo in here which I need to address because I can't spell. Candidate, not candidate. That threw me off a little bit. So yeah, candidate ID. This time around, I'm using an int, not a tiny int, because I know we're going to have a lot of candidates by the time, this database hits production, which would be in the year 4000. So I want to accommodate for that. It will be tedious if I make a tiny int and we have to change it to int, to big int, small int, and so on. So we want to avoid those, okay? I just noticed, okay, never mind. All right, so yeah, again, similar to everything we did, the same with the name. This time around, I made the name to take up to 255 characters. If the name looks anything like mine, you probably need maybe half of those characters, okay? Again, candidate votes. I'm not sure if it's going to get to 1 million or 2 million, so let's just keep it int. and int also for total votes. So again, remember the range. For int, we could get up to 1 billion. Sorry, 2 billion and something. All right. Important. Election year. Election year, again, I'm using small int, not int because int is too large, and not tiny int because tiny int is not going to accommodate for 2000. So 32,000 is about right for me and you to live for the rest of our lives. So we should be good to go. Election year, small int. Party ID is going to connect to the party table right here, and state ID is going to connect to the state table right there. And how do we enforce this? We create a foreign key for the party ID and reference it to that table and a column. We also do the same for state ID to that table and that column. And we make sure, hey, when you delete, no action should be done. If you update, no action should be done, and very good. Also, for performance, you want to go ahead and create indices, create an index for, give it a suitable name, which is unique. So maybe you want to use a particular prefix index on the foreign key, candidate party ID for USA candidate, and you're good, and so on and so forth. So that's it. With this, I can now execute this query, and I should be good to go. If I execute it, it tells me it cannot find USA candidate. Oopsie. That's because I changed. That's on line 32. Sorry, line 35. That's because I changed the name of my table, but I forgot to change it down. So I changed it here, but I forgot to change it in my index. So let's change that right there. Excellent. So we should be good now. Executed. Yeah, the first part already executed fine. So it's yelling back at me because it already knows this is there and that is there. So everything executed. The only thing I needed to do was to execute this, which I have done, and now it's successful. So if you don't want to execute the whole script, you can go ahead and select the lines of code you want to execute, and you should be good. All right. So let's go ahead and refresh the database or just the tables to see if our table is in there. It should be in there for sure. So we have our tables in there. We can now go ahead and close this. Yeah, maybe I should save it this time around. So yeah, we went ahead, designed and normalized those. We created the normalized tables. We made sure all of these best practices are taken care of. The appropriate names, data types, constraints, indices, all done. So all we need to do now is insert the data that we imported. Before we insert the data, let's make sure first of all that we validate that the data in the normalized tables is good. It's simple. Right click, just like we did earlier. Check out the states. Nothing is in there. Oof, it's blank, it's empty. But that's fine. Let's go ahead and check out the party as well. Right click, check it out. Nothing is in there, just the empty structure without any data. The same with the candidate, we don't have anything in there. So that's good. No worries. We should be good to go once we do the next part, which is inserting the data. All right, let's go and open that file as well, which I created. And file, insert the data. So it's not that long, it's very short, and it's made up of 3 sections. The first section, we're going to insert the state. How do we do it? We use insert into with a select clause. We're saying we want to insert into this USA state table, and what we need to insert is these columns: the name, the abbreviation, the FIPS, the SEN, and the IC. And we pull that information by selecting it from our existing table, which is right there, the imported table, which is unnormalized. So again, I'm going to highlight just this and execute it. Yay, 51 records were imported because I made sure that I use a distinct key. I don't want to duplicate my records. All right, so duplicates, not a good thing. We can go ahead and check that out. Right click and select top 1000. There you go, everything looks good. Pulled in neatly. We checked a second ago, it wasn't there. Now we can close that. We go on to the next step, which is populating the party table. Party table is really small, but there's a fancy thing we need to do. So we're going to do again our insert. This time around, we need to insert name and the abbreviation. For the name and the abbreviation, we're going to still select a distinct simplified name, but we're also going to need to use a function. We use a substring. We get that simplified name starting from the first letter and counting 3 characters. It's going to give us DEMREPLIB and OTH and so on. All right, so that's how we insert that. Notice that we are not inserting the party ID or the state ID, but because we created it as an identity column, it automatically does that for us automatically. All right, let's execute this. 4 records were inserted. Let's check out the party. You should be able to see. Yay, the party ID was inserted for us. All the rest of the information. These are null for now. We can come in and insert them later on, modify the table or modify the data and so on. So it looks good. One more to go and we should be good. So inserting this, populate USA candidate table. Again, inserting into the candidate table, we need a few things to insert: the year, the candidate's name, votes, the total votes, the party ID, and the state ID. Let's pull this down so we can see clearly what's going on. And all that information is going to come from, remember that year, that is coming from the imported table. The candidate is also coming from there. The candidate votes is coming from there. The total votes is coming from there. But I don't only want to pull from there. I also want to pull it based on the party ID that I already have in my USA party, where my party name matches this name that is coming from my OT. OT in this case is that original table, okay, that I imported. So I'm tying that original table I imported with the candidate, sorry, with the party and the state. The second one here, as you can see, is the state. Also using a where clause to make sure that the name and the party match. And that should be good. Once I do that, I should be able to import or insert rather all the required information neatly. And let's execute this and go from there. I selected it and execute. Invalid, yay! Obviously, I forgot to change the name to candidate. Excellent. And it tells us invalid object name because it doesn't see T, it sees D. And it tells me the line 20. That's why it's important to have your line numbers, and I could easily identify where my issue was. Awesome. Let's execute that. Now it's good, and we see that familiar number again, and we're all good to go. Now let's double check that it's good. Select top 1000. Yay! Our data looks clean. Now we just need to make sure that it's related. The candidate is related to the party, candidate is related to the state. So how do we go about querying this information? I'll show you a very good way for those who are visual learners like myself. Let me save this, that'll be good. So now we validated everything. Now it's time for us to enjoy using SQL to do some fun stuff, all right? So how do we do that? Let's start by creating a new query. We can do that by right-clicking here, new query, or making sure we select query on there and we're in the right database. Now that we're looking at the query, instead of typing each one of these manually, we can go into the query menu and select design query in editor. So we're going to design the query in editor. It pops up and gives us the name of our tables that are within this database. Now, if you're in a huge enterprise or company or industry, you might have way too many of them. But remember that in parentheses, it's going to tell you what schemas. Some tables might look like they're duplicates, but their schemas are different. So be very, very careful if you're using this. Make sure you pay close attention to detail. Also, views, functions, and synonyms can be viewed in there. We are not concerned with that. I'm going to move this to the side so you can see this section, what happens. If I double click on the candidate, it gets populated in my query designer. I can't touch it right now because of this pop-up. I can also select multiple tables by using the shift key or just dragging, or the down key on my keyboard, and adding them in there. So you notice what happens when I add it. It gets connected to those based on the referential integrity that I created with the primary and foreign keys. Now I'm done inserting the tables. I can close this and I can take a look at what this looks like. So the query designer is useful for visual learners. Okay, it gives you an idea. You can actually see what your table structure looks like. In here you can create your query just like how you created a query with, I should move this to the side and put this in the middle. There you go. Just like how you created a query using your keyboard, mouse, and typing it out. So from here, everything you select is going to show up here. You see the column, the alias, you can add it if you need, the table is coming from, if it should be shown in your output, how you want to sort it, the filter, which is a where clause, and other options. All right, and the actual code is outputted at the bottom. The problem is you can see how long the name of the objects are. We're just looking at the schema name and the table name. If you add the database name, it's going to be even longer. So now we're going to start doing something like, say, the candidate information. Let's get the candidate name. Click on that checkbox, it shows up. The candidate votes, it shows up. We can even drag and drop them down there. So let's start with the year. You can drag that and put it here. The year shows up and it gets updated each time you make those changes. So here you can see the election year, the candidate name, and the candidate votes. Those are the three that I've had so far. You can also use the where clause. Let's say, where is my filter? Let's say here I want it to be equal to 2020. It gets added in my where clause. So it tells you where the election year is 2020. All right. Anything else I'm missing? Maybe I should add the party name. So I can pull it from here. And party name, I probably needed the state as well. I need to move this up. There you go. And the state name, you can always, rearrange them. Once you're done doing everything you need to do, all you need to do is click OK. Once you click OK, that code gets inputted. Let's zoom this in a little bit. Actually, I should just do word wrap. So if I'm not sure where to get that word wrap shortcut, I can go ahead and just type it up. Here's my word wrap. There you go. Excellent. The other thing is you get all these red squiggly. It's not very good for the eyes. One thing you might want to do is turn off your IntelliSense. You can do that again. Start typing IntelliSense. It tells you can turn it off here. And enable. Nope, we want to disable IntelliSense. And from there, you should be able to... it didn't go. Let's try it again. IntelliSense. IntelliSense. There's one that should just say enable. There it is. Now it's disabled. Awesome. Now, where were we? Yeah, the code wasn't created for us. All we need to do is execute it. Once you execute it, there you go. It shows us everything from 2020 and the values. Again, SQL does not really have all the fancy bells and whistles for visualization. That's where you have other tools like Tableau, Power BI, and so on that come in. This will help you run through your query, do some fun stuff, and then you can output the result. As you see in here, you can click here to select everything and paste it, or instead of outputting your result to the result grid at the bottom, you can output to a simple file or to a text file, and so on and so forth. So it tells you how many records you selected and so on and so forth. So you can also set up a link to a file, two-way link and so on and so forth. Now, let's look at a few fun queries that I had. I'm pretty sure we've gone above time, but bear with me here. Need your assistance or your attention for a minute. There are 5 of them actually. I tried to do some low-level stuff. So let's open the first one. Again, very simple query. We're going to get the percentage of Republicans and Democrats by year. Pulling all that information. The most important thing is those joins. Okay, we're joining the candidate to the state using the state ID. We're using aliases like C and S. The mnemonic C for candidate, S for state, P for party. So we're connecting 3 tables here. Okay, we join the first table on the state, the second table on the party ID, and then you use a where clause to specify that, hey, I want just 2020 information, and I also use the party abbreviation to say, give me just Democrats and Republicans. All right, we're using the in clause in here just to note that for performance issues, you definitely want to use in rather than saying where abbreviation is equal to Democrats or abbreviation is equal to, yeah, that's going to be a pain. It takes up resources. It might not be a big deal for a small data set like this one, but you want to make it a habit to avoid using or. If you can use in is going to be more efficient. All right, so let's undo this and leave it as it was. So I can go ahead and execute this, but before I execute, I already learned my lesson that I need to rename it the right way and execute that. So it gives me the results. And the key thing here is on line 10, we have a long looking column, which I want to break down to you. At the end of the day, we are going to call it percent votes. That's why it looks neat here, percent votes. But how do we get it? First of all our votes and the total columns, as you can see in here, they're coming from the candidate. They are both integers. Okay, so the votes and column are integers. So if you divide them, it's probably going to give you 0 or 1, depending on how close the numbers are, because dividing integers will give you 0 or 1. So we need to convert the integer, at least one of them, to a float. Float again is short for floating point number, which is a decimal. So if we convert one to a float, in this case, we started with candidate votes divided by total votes, then we end up with a decimal at the end of the day. But we want to also multiply it by 100 to make it percentage. all right, after multiplying by 100 to make it a percentage. If we don't round it to one decimal place, we're going to have some really long number right here, which is not going to be pleasing to the eyes. So we round it to one decimal place and we're good. If we wanted 2 or 3 decimal places, let's say 3, you can still do that and 3 would be in there. And if you don't do that, it's going to end up with some really long, nasty numbers at the end of the day, which we want to avoid. So that's how we go about doing that simple calculation. From here, you can see the percentage from each one. You can export this and, or simply just link it to an Excel file, and you should be good to just refresh it. So that's a quick one, right? The main thing here was just understanding line 10, how you go about nesting functions and also using simple functions for transformation. Very useful for ETL. Let's jump into the next one. Open file number 2, top and bottom. Yay, this is a good one. So we're going to see the number of the candidates that have the most votes over all the years, right? So we're pulling the candidate's name, the election years, the sum of all the candidates' votes across all the states, all right? So, and we call it candidate grand total. Again, we're going to join those tables like I told you earlier, the state, the party, and the candidates, which I should name. We're going to do this quite a lot. All right, and then this time around we're using aggregate functions. All right, we're going to group it by the candidate name and the election year. We cannot group it by one, we have to group it by both, otherwise we'll have an error message. The only thing that doesn't need to be grouped in the select clause is if it has an aggregate function. So once we do that, we also want it to look neat. We're going to make sure we order it by the grand total. Again, the order of operations helps us to use this alias because the order by is the very last clause that runs, because it doesn't really create any result, it just modifies the result, sorts it out. So if we execute this top one, we can see that in 2020, Jeffrey had 0 votes. That's interesting. Jeffrey did not vote for themselves. And there's a bunch of people in 2020 who had 1 or 2 votes. Hopefully we don't have that happening this year in 2024, but it is really, I don't know if I should say annoying or fun. But yeah, so that's looking at it from the bottom to get an idea. People were more serious with voting in the days past. You don't see anything here from the 1990s or the 80s, except here we have 20 unaffiliated people voted in 1992, 22 voted for prohibition, and so on and so forth. So those are some fun facts you can get from your data. You can always change this to go descending or just scroll all the way to the bottom since it's just 230 records. And you should be able to see, no, I'm too lazy to scroll from the bottom. Let's just go ahead and change that to descend so we can see the top. Yeah, so the person with the most votes in history is Mr. President Biden, followed by President Trump. So they had some huge numbers, very, very huge numbers. And you can also see the turnout in the previous years, all right? So again, it's the same query. In this case, the second case, I'm actually doing it by state. So instead of doing it by year, we do it by state this time around. And let me select just that. And again, the difference is here we had candidate name and election here. Here we have candidate name and state name. So we're not doing it by year, we're doing it by state. Let's execute that and see what happens. So yeah, California always has the most population. So California is always going to have the most votes, as you can see, followed by Texas. And we don't have the year in here, so it's just grouping everything according to the states of that year. So again, Donald Trump shows up multiple times in here, President Trump, because they are for separate states. For Texas, California, and Florida. Those are all separate. Awesome. So that's another fun way you can dive in. You wouldn't be able to do this easily with Excel. You can do a lot of powerful computations in there. So let's check out another one. I think this should be the last one. If you need us to look at more, please drop me a message on the comments and I'll go ahead and demonstrate the rest of them. State percentage, I don't know if we want to look at that or we want to look at average votes. Let's just look at the trend over time. Yeah, this one is going to be a little bit more tedious. So trend over time, again, we're selecting party name, election year. We're adding all the votes for a particular candidate, all right, from the same tables that we're looking at, those 3 tables this time around. We're going to group it by party name and election year. So we see the grand total, the trends over time. If we execute that, oops, forgot this time around to update the name of my table. Let's pull this down, it's too large, there you go. And execute. And funny, I have to pull it back up. So again, over the years, you can see the number of votes that have been coming in from 1990. Okay, so it's looking at the trend. Wondering why I don't have 1976. Oh, never mind, it's right there. Awesome. So 1976 had quite a good number of voters. People stopped voting about then, and the turnout dropped, and then it went on. So something like this is something you can always go ahead and plot on a graph to get a visual to see how the turnout has been affected over time and so on and so forth. So again, this one is similar, but this time around we're also looking at states, and you have uh, multiple predicates. You know, you have a where clause with complex predicate per se compound with the party selected and also the actual state. I'm using an abbreviation in this case, and as usual, this is the last time. As usual, we forgot to change the name of the column or the name of the table. So yeah, this gives us an idea of the turnout of voters, you know, from 76. It has been steady. Is it? Or is it because of the way yeah, it's because of the way I ordered it. I ordered it by election year, party name, and state. So election year, party name, and state. So you can see the voter turnout for each of these. Awesome. So that's about it. Again, just wanted you to get comfortable writing these queries. There are a lot of other queries that we can write. The key here, we had to go through a few things, you know, to get the CSV into a normalized database or normalized set of tables that are related. We saw how we can create a query from the query designer and also use some scripts that I created on checking those out. So from here, we can always just go ahead and say, looking at the last one, copy this, right click and copy. You can copy with headers and switch over to our Excel file, maybe create a new tab and throw it in there. That's taking a minute. How about we use this one? Awesome. And from there, you can go ahead and create a timeline, a graph, anything else that you need, and you're good. You know, Excel or Sheets has a convert table thing that you can always use and so on. Awesome. Very good. So let me know what questions you have. Anything else you'd like me to show or see should be good to go. And I hope you had fun with this. Next one is going to be on Python. You see how powerful Python is. It's going to merge all of these. So understand that all of these complement each other, okay? They have their strengths and weaknesses depending on what you're doing. You know, there are many tools out there that depend on SQL. Understanding what's going on here in the back end lets you be able to tinker things and troubleshoot any issues that you might have. You also validate your output and so on and so forth. All right. Excel is cosmopolitan. Everybody, or ubiquitous. Everybody knows how to use it. Everybody actually knows about it a little bit. But Python, you know, there's a learning curve, just like SQL. Python is a whole programming language by itself. It does a lot of other things. You know, it's progressive. It's something that you enjoy. It's fun. So it's up to you what level you're in, how comfortable you are, the business you're in, what your team needs to be able to do the best you can with any of these tools. But understanding each one of them is imperative if you're going to be working with data. All right. Enjoy the rest of the day. Catch you on the next video. You already know who it is. V2DK. You already know.